Hello, sir. My name is Rishabh Sinha. I am from Kolkata, West Bengal, and currently I am pursuing a master's in artificial intelligence and machine learning at AlmaBetter. And today, this is my third project of module three, that is product dissection. So I have taken the topic as Uber. The product that I have taken is Uber. So let's begin with the product direction for Uber. So company's overview. First, the company's overview is Uber technology was founded in 2009 by Garrett Camp and Travis Camp. It is a global mobility as a service platform that helps customers to travel from one place to another, that has transformed how people move, earn, and connect in the urban environment. Initially launched as a simple app for booking black cars in San Francisco, it started in San Francisco with black car services in San Francisco, and now it has reached globally. Uber has evolved into a multi-service ecosystem offering ride-hailing, delivery, Uber Eats, freight, and business solutions across 10,000 plus cities all over the world. At its core, Uber operates as a two-sided marketplace that connects riders seeking transportation and the drivers providing it. So it is a two-sided business where where the riders who want to go from one place to another seek drivers, and the drivers seek customers to get rides from. The platform's success lies in the ability to combine real-time location data, advanced algorithms, and dynamic pricing to create an efficient and scalable system. Uber eliminates the inefficiencies of traditional taxis systems to enable quick, transparent, and safe rides at the tap of a button. So Uber basically guarantees you a safe, and transparent travel from one place to another without waiting for the traditional taxis that we had in the previous times. So the key proposition of the company is on-demand mobility. So whenever you want it, you don't have to hail street. You can get whatever you want by the tap of a button. Second is transparent upfront pricing and cashless payments. So second is you have the option of knowing what they will charge, that is transparency, and also they accept cashless payments. The third is real time tracking. You can track your location, your ride real time. The fourth is mutual rating for accountability and service quality, and the fifth is opportunity for flexible driver income. So the drivers also get a flexible opportunity to earn money. Data driven matching for reduced idle time and efficient routing. Okay, so let's begin with the product dissections, real world problems, and Uber solutions. Uber was designed to solve persistent transportation and service efficiency challenges in modern cities. So modern cities basically have too many crowd that wants to travel from one place to another, but there are less options for them, or maybe not that transparent. Where there are cases where they get transport at a high price, or they do not get a transport from where they want and where they want to go. So Uber has bridged that gap. So the first problem was real world problem was lack of reliable and instant transportation. So there before Uber, there was a problem of lack of reliability of the cab drivers, or the taxi drivers, that they will go or not, or if they will go, then they will drop you at the specific location you want to go or not. And the second was instant transportation. They had to wait in queues for taxis and something, but Uber has bridged this gap. So Uber's solution was Uber's on-demand ride-hailing system leverages GPS tracking and intelligent dispatch algorithms to match the riders with the nearest driver in seconds, so that you don't have to waste. What was the impact is reduced average waiting time from 15 to 20 minutes. It has saved the waiting time. Second is greater accessibility in suburban areas and high demanded areas. Both they were high demanded areas and suburban areas, they have access to it. And the third is consistent pricing and transparency. Second problem was unbalanced supply, demand, and surge situations. The real world challenge was during events, rains, or rush hours, the demand for rides were too much, and the taxis or the services were too low. So Uber has bridged this gap also. How they have, let's see how they have done. Uber introduced dynamic pricing. They have made dynamic pricing even at the at the surge pricing, a real-time algorithm that increases fare when demand exceeds supply. Higher fares incentivizes more drivers to go online or move to high demand zones. As supply increases, price automatically returns to normal. This market clearing mechanism ensures efficient allocation of resources without manual interventions. So there was in the during the rush hours, the taxi drivers also want high pay for their rides. So Uber has bridged this gap by increasing the rates at the rush hours and decreasing it during non-rush hours, and that also not too much high or too much low that the riders could not afford it. So impact was reduced unfulfilled ride requests, keep rider wait time predictable, enables drivers to earn more during peak hours, improving retention. Third problem was safety, trust, and transparency in rides. So basically, as you know, safety is the first main concern of everyone. Riders were often hesitant to share cabs with strangers due to safety concerns, and drivers lacked protection against false complaint or unserviced rides. So, how Uber has bridged this gap? Uber embedded safety features across the rider and the driver experiences, verified profiles and background checks for drivers, SOS emergency buttons, and live GPS trip sharing for the riders, real-time ride monitoring, driver face verification, and trip auto recording. And the fourth is mutual rating system that encourage accountability. You can rate if you have a bad experience or good experience. If you can also rate likewise. Fourth is ability to block or report unsafe interactions. So what impact this has done? Sustainable, uh, sus, sus, substantial decline in fraud and safety incidents, transparent post-trip review data for continuous quality improvement, strong rider confidence leading to higher retention. Fourth is cash handling and payment sections. So Uber in the traditional taxis they had cash policy that you have to pay in cash only, but Uber has bridged this gap by introducing online payments or UPI accounts. You can use your UPI payments or any other online transactions. Eliminate or you can import in the Uber app also money in the Uber app also Uber Cash eliminates what is the impact eliminates cash management and fraud risk, enables automated driver settled and trip and tip tracking, simplifies accounting, reduces refunds and promotional credits. Fifth is underemployment and flexible work needs. So there, as you know, underemployment is one of the most biggest problem globally. So Uber has bridged this gap to a certain extent by providing drivers worldwide to get a chance to earn from Uber, and also bridge the gap. And also they have given fixed flexible work timings that whatever time you want to drive, you can drive it. You have to just log in and log out. So impact this has done is democratized earning opportunities for part-time and full-time drivers. You can work as a full-time driver also and part-time also. Reduced urban unemployment and increased economic participation. Fourth is data-driven driver engagement and reward programs. So top features support in the schema is features that support the schema is user account. Second is vehicle and driver profiles, documents status, trips that's life cycle, real time telemetry, pricing, rating and feedbacks, payment and transactions, zones, and support and incidents reports, safety. So the schema design. Let's begin with the schema design. The first schema that we have taken, first table that we have taken is the users table. In the users table, we have, as you can see, we have the primary key is user ID, a unique identified for each user ID. Then after that, there is an email, phone number, and full name. That means the details of the user account section. Third is user type. That means it is a rider or a driver or admin. Fourth is verified or not. If the driver is verified or not. Fifth is rating average. What is the rate of the driver? And sixth is created at or last activated at, last active at. That means when was he last active. The second table that we have made is driver profiles table. It will give us the details of the driver. So driver ID, like there was a user ID, now we have the driver ID. Second is vehicle ID, his vehicle, the driver's vehicle ID. Third is license number, license expiry date. Okay, license number and license expiry date. Fourth is background check status. What is the background? They have checked the background and what is the status of the background? If he is fair or he is not. Online status that means available for the trip or not. Fifth is acceptance rate, that and earning total. What is the acceptance rate? How much uh, cabs do how much rides do they accept or not or reject them? The third is vehicle table. So in this vehicle table there is a vehicle ID, vehicle ID of the vehicle, the primary key. The their foreign key is driver's ID. Then make, what is the company, what is the model, what is the year of the car, and what is the plate of the car. Fifth is capacity, how much sitting capacity is there, and vehicle type of the vehicle, that means it is a sedan or SUV or Lux. Fourth table is trips table. Yeah, fourth table is trips table. So in this first column that we have taken is primary key is trip ID. What is the trip? That means for every trip there is a different ID. So first is trip ID. Second, there is a foreign key that joins with the user ID, user table, that is rider ID. Third foreign key is driver ID, that also merges with the user ID. Fifth is pickup at and pickup pickup latitude, pickup longitude, dropping latitude and dropping latitude and longitude. The pinpoint area, worldwide pinpoint areas where they have picked up and where they have dropped. Then after that, there are sections like requested at, matched at, started at, completed at, where the request was matched, where they have started the trip, where they have completed the trip, if they have cancelled the trip or not, then where they have cancelled. Status, that requested, matched, started, completed, cancelled. Then the distance in meters and duration in seconds. The other column is estimated fare or final fare. What was the estimated fare and what is the final fare that was charged when they reached there. Surge multiplier, how much surge multiplier is there, that means during rush hours. And the foreign key at the fifth, the last column in this ID is this table is payments ID, that is a foreign key that joins with the payments table. Fourth table that we have taken is driver location events table. Driver location event table. In this table we have three columns. First is event ID, that is a primary key. Second is driver ID, that is a foreign key. Third is latitude, longitude, heading, speed, reported at. After that, there is a ratings table. Ratings table, it has rating ID, primary trip ID, rater ID, ratee ID, ratings, comment, what is the comment, and created at. Next is the payments table. We have taken the payments table. In the payments table, there is a payments ID. Every payment has a different, they are given a different ID, payment ID, trip ID, rider ID, total amount. What was the total amount? Amount, driver, Uber commission amount the driver got, amount commission the Uber got, taxes, trip amount, currency, status. What was the currency and what is the status, pending or completed or failed or refunded. Payments method, that online transaction or cash or something. Processed at, where was the location that it was processed. The next is payment method table. So in the payment method table, there is a payment method ID, that what method was used, online or cash or something. Second is user ID, user who has given the payment. Method type was card, either they are paid by card or wallet or UPI or cash. After that, masked details. There are some more details that are masked from normal people. After that, there is zone tables. Zone tables. So in the zone tables, there is a zone ID. After that, there is a name. There is a geo JSON, and there is a search table. Zone wise, what is the search and something. Next is the incidents table. In the incidents table, there is incident ID, trip ID, reporter ID, reported ad ID, incident time, incident type, status, and notes. That if there is an incident or accident or something for the safety of the customer. Next is the drivers earning snapshot table. So it has snapshot date, driver's ID, trip counts, gross earning, and net payout. How much the driver earns. Next is the promotions table. What is the promotion table? It has the promo ID, then it has the code, discount type. That every way that the company promotes, like by giving discounts or giving a code or coupon or valid up to what till what date it has a valid. All this has to be in the database of the company. So it is contained in this table. Next, what is the relation between tables? So user ID and driver's profile ID has a connection. One user can have one driver profile. One user can have one driver profile. Relationship one to one. Next is users to vehicles. Users to vehicles. User ID, user table to vehicles table. Each driver oblique user can register multiple vehicles. Each driver can register in multiple vehicles. He can use multiple vehicles. Relationship one to many. User trips. So user and trip, there is connection between user and trips also. A rider can take many trips and a driver can complete many trips. The driver can also take many trips and the rider can also take many trips. That means one to many from user to trips. Relationship is one to many from user to the trips. Next connection is trips to payments. Every trip has one payment record linked to it. One for every trip you have to pay once. Therefore, the relation is one to one. Next is trip rating. Trip rating is each trip has multiple ratings from riders and drivers. Each trip can have multiple ratings also. Relationship one to many. Next is trips incidents. A trip can have one or more reported issues or compliance. Relationship one to many. Next is user ratings. User ratings. User can rate others users a- after a trip. So relationship is many to many handled using rater ID and ratee ID in a rating table. Next is user payments. User to payments. Each rider can make many payments across trips. Relationship one to many. Each rider can make many trips across trips. Across different trips, he can make many trips. What is the next connection? Next connection is relation is users and payments method. A user can save multiple payments method. You can save card also, UPI also, cash also, card, UPI, etc. Relationship is one to many. Next is trips to driver location events. During one trip, many location updates are recorded for tracking. So for one trip, many locations are tracked, like from where the booking was done, from where the trip started, from till where the trip ended, like that many. So the relationship is one to many. Next is trip to zones. Each trip belongs to one zone, depending upon pickup location. Therefore, each trip has one zone. In one zone, depending upon the pickup location. So, many to one. Next is payments to promotions. A payment may have one promo applied to it. Relationship is many to one. Next is driver's profile vehicle. A driver's profile is linked with one main vehicle. Relationship one to many. The next is driver's profile to driver's earning snapshot. So a driver can have multiple daily earning entries. So one to many. A driver can earn many times in a single day by many different trips. So I have made an ER diagram in SQL, MySQL. I have written the codes and made a schema. I made a ER diagram, as you can see, and it has represented all the connections that we have mentioned above. All the connections you can see, like in the payments and incidents, there is a trip ID and trip ID is connected. And what are more, they are connected. Yeah, trip ID is connected. Likewise, you can see there are many, all the tables I have made, all the 1 2 3 4 5 6 7 8 9 10 10 tables, and I have presented all the connections they have. So in the conclusion, we can say that Uber's journey demonstrate how data driven architecture and schema design directly shapes Uber's experience, users experience. By dissecting its platform, we understand that every Uber feature for from instant booking to surge pricing and safety alerts is powered by an integrated networks of entities, attributes, and relationships that all we have learned. The attributes and relationships that we saw in the project all are merged together in a database into different tables, and with that database the company is made, the product is made without us, without removing one or two tables or certain parts of it, the product becomes incomplete for us, the chain is broken. So surging prices and safety alerts is powered and by an integrated network of entities, attributes, and relationships that mirror real world interactions between riders, drivers, and the system. Uber schema is not just a technical blueprint. It reflects the philosophy of mobility innovations. It is a mobility innovation, innovation in mobility, empowering user with transparency, balance marketplace efficiencies with fairness, use data as the backbone for trust, scalability, and safety. Through effective schema design, user converts complex real-time logistics into a seamless user journey, redefines how millions move every day. This dissection highlights the vital connections between product thinking and database architecture, where thoughtful data modeling drives real-world impact. So, with all this data, all this data and complicacies, the company is merged using all these data, and you can see that it has become a marvel that by using data it has earned so much trust, so much safeties, and it has gone to such a large scalability, as you can see, and it has in a way become the backbone of mobility nowadays. So with that we complete the project. Thank you so much.